Good afternoon, students. Today is the session 2 from the chapter of moving charges and magnetism. And in this session, we will be discussing about the Lorentz force. Now, the definition of this Lorentz force is that if a point charge moves with a velocity v in the presence of an external electric and magnetic field, then it experiences a total force which is given by F is equal to Q. I will written this is in bracket E plus the cross product of V and B. So this can also be written as Q E plus Q multiplied by the vector product of V and B. So this QE is the electrostatic force which that charge is experiencing, and Q multiplied by the vector product of V and B is the magnetic force which it is experiencing. Now this equation was given by a Dutch physicist by the name of Hendrik Lorentz, so this equation is also known by the name of Lorentz force. Now with the help of this equation, we can conclude few with the help of this equation, we can draw few inferences based on this equation. That is, the first one is that if the charge is stationary, that is, if V is equal to 0, then the magnetic field is 0. That is, if the charge is stationary, then magnetic force will be equal to 0. The magnetic force on the charge will be 0. पहला चीज तो ये हो गया. Second thing, the value of this force depends on the intensity of the electric field, the velocity of this charge, and the intensity of the magnetic field. ये आपका F is, that is the total force on the charge, is directly proportional to V, B and Q. This is the second point. Now this magnetic force जो है, this is the electrostatic force, that is F is equal to QE, and this is the magnetic force. Now this magnetic force जो force है, this is given by Q multiplied by the vector product of V and B. ठीक है. Now इसका मतलब क्या हुआ कि जो हमारा जो ये magnetic force है, this will always be, or you can say the direction of the magnetic force will always be perpendicular to the velocity vector and the magnetic field. This is because this is the cross product. For example, अगर मैं यहाँ पर एक छोटा सा एग्जाम्पल लेता हूँ. मान लीजिए ये आपका x एक्सिस हो गया, ये y एक्सिस है और ये z एक्सिस है. Now let us say the charge is moving along the x axis with a velocity v. ठीक है. And the magnetic field का जो direction है, let us say it is along the z axis. ठीक है. This is along the z axis, like this. So the magnetic force क्या होगा? The direction of the magnetic force will be perpendicular. This is the cross product. That is, magnetic force is equal to Q multiplied by V, multiplied by the cross product of V and B. Now, this velocity vector can be written as V dot I cap, and this magnetic field can be written as B dot K, where I and k are the unit vector along the x axis and the z axis respectively. So अगर आप मैग्नेटिक फोर्स का मैग्नेटिक फोर्स लेट अस व्हिच इज अगर मैं इसको लेता हूँ, सॉरी, if it is let's say FB, then this would be equal to Q V I into B K, and the cross product of I and K, that is the is equal to, ये आपको क्या मिलेगा, this will be equal to dot ये आपको आ जाएगा, ठीक है ना. So the magnetic force will be along the this y axis, and y axis का मतलब क्या हो गया कि that is this magnetic force will be, the direction of the magnetic force will be perpendicular to this velocity vector as well as the this magnetic field. So the magnetic force is always the direction of the magnetic force is always perpendicular to the velocity vector and the direction of the magnetic field, and this it is given by this relation, that is magnetic force is equal to Q multiplied by the cross product of V and B. Now this equation, that is the Lorentz equation, can also be written as QE plus QVB sin theta, where theta क्या है, theta is the angle between the, it is the angle between the velocity vector and the magnetic field. ठीक है. This Lorentz equation जो हमने अभी just लिखी थी, जो मैंने, that can also be written as QE plus QVB sin theta, where theta is the angle between the velocity vector and the magnetic field. That is, अगर मैं इसको एक छोटे से एग्जाम्पल से यहाँ पर समझाने की कोशिश करूंगा. लेट अस से दिस इज ए, मान लीजिए ये एक यहाँ पे चार्ज है और इट इज मूविंग इन दिस डायरेक्शन विद द वेलोसिटी v, एंड लेट अस से दिस इज द डायरेक्शन ऑफ द मैग्नेटिक फील्ड, दे आर मेकिंग एन एंगल थीटा. सो ये जो आपका जो दिस आपका जो मैग्नेटिक फोर्स है, वो ये जो है, इट विल बी एक्टिंग in this direction, that is F will be acting in this direction, and this F will be perpendicular to both this magnetic field and the velocity vector. ठीक है. So F is equal to QE plus Q will be sin theta, where theta is the angle between this velocity vector and the magnetic field. So यहाँ से एक और चीज हमको यहाँ से we can draw one more inference, that if theta is equal to 90, then this F will be equal to QE plus Q. If theta is equal to 90 degree, then F will be equal to QE plus Q VB. और अगर थीटा की वैल्यू 0 हो जाती है, तो उस केस में ये जो मैग्नेटिक फील्ड है, सॉरी जिस मैग्नेटिक फोर्स है, उसकी जो वैल्यू है वो 0 हो जाएगी. और अगर थीटा की वैल्यू आपकी 180 डिग्री है, दैट इज इफ द वेलोसिटी वेक्टर इज पैरेलल टू द मैग्नेटिक फील्ड, दैट इज व्हेन थीटा इज इक्वल टू 0, और व्हेन द वेलोसिटी वेक्टर इज एंटी पैरेलल टू दिस मैग्नेटिक फील्ड, दैट इज व्हेन थीटा इज इक्वल टू 180 डिग्री. अगर थीटा हमारा 180 डिग्री है, इसका मतलब है द वेलोसिटी वेक्टर एंड द मैग्नेटिक फील्ड दे आर एंटी पैरेलल. और अगर थीटा जो है मेरा 0 है, इसका मतलब ये हुआ कि दे आर, द वेलोसिटी वेक्टर एंड द मैग्नेटिक फील्ड आर पैरेलल टू ईच अदर. सो इन बोथ द केसेस द मैग्नेटिक फोर्स क्या हो जाएगा, दैट विल बी इक्वल टू 0, बिकॉज द मैग्नेटिक फोर्स इज गिवन बाय द, लेट अस से इसको मैं डिनोट करता हूं FB. मैग्नेटिक फोर्स इज गिवन बाय QVB sin theta. तो अगर theta 0 हो जाएगा, that is when the velocity vector and the magnetic field are parallel to each other, then the magnetic force will be 0. And if theta is equal to 180, that is when the velocity vector and the magnetic field are anti-parallel to each other, then also the magnetic force will be equal to 0. Okay, now the important thing is that the Lorentz force is equal to F is equal to Q E plus Q multiplied by the vector product of V into B. Okay, first thing. Second thing, the magnetic force is always perpendicular to the velocity vector and the magnetic field. Third thing, this Lorentz equation can also be written as F is equal to QE plus QVB sin theta, where theta is the angle between the velocity vector and the magnetic field. If the velocity vector and the magnetic field are parallel to each other or they are anti-parallel to each other, then the magnetic force will be equal to 0. And the direction of this magnetic force is given by the right hand thumb rule.